Hello and welcome back, and that is right. Today we are looking at Plex Media Server on the new Synology DS3622XS Plus. Not a very cheap NAS, but by all means the most powerful desktop NAS in their entire lineup. And I know a lot of you are looking at the Synology platform in order for you to host your own Plex Media server for you, your friends, your family, and maybe you've got a particularly dense library of media there. Well, today we're going to be running the same test we've always done for synchronicity on this NAS system, but with a few little tweaks along the way. So first and foremost, it's worth highlighting again, we've already set up Plex Media Server on this NAS. You can see the performance there running quite smoothly there, quite low. This is utilizing a 6-core processor internally. It's an Intel Xeon D1531, which is a 6-core processor there. It's also got 16 gig of memory. It's a 12-bay NAS. We've only put 2 hard drives inside. We're using the Synology HAT 5300s inside there. And we are utilising the same files that we're always utilising in our test. We've got some 720p, 1080p, and some pretty aggressive 4K HEVC and H.264 files to get through. Also, we are using OBS, so hopefully there won't be any blips along the way. And of course there we will be monitoring the performance of this NAS here on the dashboard. So before we go any further, it's worth remembering, if we go into the settings of this server, have a look at the management settings, we can see we are utilizing the latest version. We're using the disposable Gmail account for the channel. If we go into DLNA, we've enabled DLNA there. We are using network connectivity here. It's worth highlighting. But don't worry, again, the sort of performance we're looking at here, I wouldn't worry too much because we're still going to make the CPU hurt, as you can see. And we are using basically transcoding at its highest degree on this CPU. But do bear in mind that this Intel Xeon CPU does not have embedded graphics. It doesn't have any kind of supported graphics component. So it will be raw power we're looking at. Now, this isn't going to prove any kind of difficulty until much later in the video when we start looking at the big files. When we start looking at some of those more aggressive files there, let's get back onto the NAS, where some of these files are going to be particularly heavy. When we get to this stage of the video, and again, if you've watched my Plex videos before, you know what you're going to see. But otherwise, if you've not, later in the video, we've got the same 30-second file here from Jellyfish. Do go to their website. I recommend it. It's covered in lots of test files for you there. Again, should be linked in the description. On top of that, each of these 30-second files being the same file is actually different insofar as the weight of them, with the heaviest one being this 400 megabits per second 4K UHD HEVC 10-bit file, which is massive there. Now, to put that into a little bit of perspective there, if we go into the file manager and make our way into the test files, head in, you can see, sorry, let's go back one. If we look at the test files there, open up those tallies just a little bit. It's the same file, all of them 30 seconds long, but look at the size of that file. It starts off at 10 megabytes, and once you go all the way down, you start seeing that file for the same 30-second footage reaches a height of 1.4 gigabytes there. So think about that. That's 30 seconds. That's 2.8 gigabytes a minute. Think about the size of some of the files in your movie collection. To put that into perspective, there is Marvel's Avengers Endgame there, the 4K UHD file, which you can stream, of course, on the Amazon platform there. And again, very heavy file. It is a 3 hours long movie there. And again, if you do buy it online, you can obviously download it and host it on your server. And if you look at some of the weight of this file, which is already particularly massive, if you own the Blu-ray of this, you are looking at a 216p, so 4K, HEVC, so highly efficient video codec, and HDR version there. Again, that still isn't as big as that file there in terms of its high density there. It's still pretty big, but it's not a 400 megabit file there. And again, if you look at the original digital cinema package for Endgame when it was first distributed, you can see even that file there of that movie weighed in the 3D version at 237 gigabytes and the 2D version at 223 gigabytes there. So that's still smaller than the file that we're talking about there. So again, when we do go through these, bear in mind that the last 2 or 3 tiers of this test You're not going to own a lot of media in this sort of scale. We include them just to really show how big these files can get. So without further ado, you know the setup, you know the files, you know we're going to use Plexus Media Server. Let's just arrange our screen the tiniest bit there. Let's have a little switcheroo. Bring that up there, get that down to the listing we want to see there. We want to get the table view, head back into the films there, and bring the test there on one side of the screen. Get that all highlighted to start initializing the first barrage of our testing. So the first file we're going to go for, as always, is the matrix. Again, not a very big file. This is a 720p file. We're going to do some transcoding tests there, but we're going to add a few extra things along the way. We're not going to worry about using bandwidth because, as mentioned, we are running a network test here. So we've got CPU and memory, and a common question I get asked in the comments, by the way. Indeed, most recently I got this question, I believe, just before starting this video. Is why do I include transcoding in these tests down to, in some cases, as low as, 240p? The reason being that a lot of people use either metadata connections, or they're streaming onto very small mobile devices remotely, or they are using legacy devices that can't handle these enormous files that we've just talked about here. So consequently, to create an artificial difficulty connection, be it on a limited format device or a device that can't support larger resolutions, or limited data connections where the file has to be shrunk so it can be received via a limited internet connection, that's why we do transcoding tests, to create an artificial example to show how the NAS will perform in these times when the file will be resized or reformatted to be better suited to the client. But for now, let's go ahead and play this file. It should play absolutely immediately. As we see there, we're running this 720p file down there at 0.7 megabits per second. Again, do remember that biggest file there and how big that was at 400 megabits per second now. That gives you some idea about the difference of what we're running here. And again, we can flick through. We're watching this movie over the network. We can flick around. Absolutely fine. And you can see the CPU hasn't done anything. It couldn't care less with what we're doing. Plex is using 0.47% of that CPU, which is nothing. So let's go ahead and start doing some conversions. Let's knock it down to 480p. Again, instant conversion there. Absolutely instantaneous. We can flick around, running fine there. Let's do another stab, get it down to 240p. A little bit more work there required. We're starting to be able to count the pixels a little bit there. But again, we can flick through. Nice and easy. Absolutely fine. We can see the CPU had to use some of its raw power to do that converting. But again, it's always going to spike while it utilizes it in those instances. And then it's going to calm down again as the buffering and the new status quo takes effect. And then if we go down to 160p, where we're going to probably have about 8 pixels on screen, on screen, you can tell I've got a tremendous sore throat today. I do apologize for that. If we have a look, we can flick along, and seemingly running absolutely fine there. Again, they are actually kissing. Don't worry, that isn't just it freezing there. And again, it seemingly handled that task very, very well. So before we go any further, let's go back to the original quality. What we're going to do is run another quick extra test while this is doing this. And what we're going to do is run multiple instances of this movie playing at once. So we're going to use the same file. We're going to play it. All these are running at exactly the same time on this NAS, all from the same file format. So let's play it there. Play the file. Let's carry on. Not sure if it'll allow us to do it. Instead, let's try a different file. Force it to play that one. Bring that up. Then get another file running at the same time. Again, we have to have them all on the screen at once, because otherwise if you minimize a window, they won't play back. So allow that to do that. This can be another person watching a film here, while all of these are running all at once. We'll have this one running Pulp Fiction. Let's play that. And again, these other two files are 1080p. So again, while we're running that file there, again, this is 720p, sorry. So we're running them all there in those file types, sorry. And as you can see, CPU still not caring less. We've still got all of those files running simultaneously. So let's run another instance of that file. We'll do another media file there. This one, we'll let it go into movies as it loads it up. So again, this could be 4 different clients all streaming. Soon we're going to reach a point where the bandwidth is going to be the only problem while we play all of these files simultaneously. So let's go in and run another file there in the background. We'll go for the Hateful Eight. Play that one. Leave that there at the bottom. And again, we're now running 4 movies from this Plex Media server, all simultaneously, all to this laptop. So right now we may see a drop in frame rate because of OBS, but that's nothing to do with the NAS. And again, the CPU there, you can see that the system is clearly running all 4 files there in the background. All of these files are running on each screen, as we can see there, although they are significantly reduced, obviously, as they play on each of these media formats. Minimize that down there so we can see it a little better. Skip forward so we can go to a scene on the playback that's not dark, because the opening of that movie is pretty dark there. But again, we're seeing all that playback, and why not? Let's try one more media playback file there, just for the hell of it. And we'll do one more media file before we move on to the next file, which is going to be our 1080p test file, which is Little Shop of Horrors. But for now, as we can see there, I think a lot of the limitations, if we open up my task manager, we have to see on screen there just how much of the limitation is being caused by me. And as you can see, now we're hitting the bottleneck of what I'm able to play back, as my CPU is clearly getting quite heavily attacked by a lot of these activities that we're running here all the way through. So again, go back to films. And again, hopefully our screen recording is still capturing all of this without my OBS failing us as we go. So let's open up Little Shop of Horrors, play that one over here. And again, no forced transcoding. There isn't anything happening. And again, we can run a couple of transcodes. We'll save that for later on. Let's go back, CPU utilization. And I think we've kind of hit a little bit of a topper there in what we're doing as it gets ready to play back that file. But again, playing all of those files all simultaneously from the same NAS, bearing in mind the obvious limitations that we're having here from my own recording laptop throughout this, rather than having 5 or 6 phones dotted around the place, it's nice that we're able to play back all of these files all at once on here with all of these different file types, all of them running together, all of them happening at once, and the CPU still not breaking a sweat there. So that's lovely stuff to see. So let's come out there. Let's exit all of those extra files there. Let's get rid of all of those. Go back to our primary window that we've been running there. We don't have any others running there in the background. So let's go ahead. Let's close the matrix there and make our way back into Little Shop of Horrors for our next test. This is a 1080p file, 1080p H.264. So let's just go ahead and play back that file. We'll start from the beginning just for the hell of it. We'll leave that file format there. As you can see, 1080p HD file. Lots of it's playing back there. We can flick along, running absolutely fine there. Again, we are running on this reduced window on the left-hand side of the screen. We can see there, system resources have gone down a little bit there. GPU is obviously getting quite hammered in terms of its percentage of usage. Remember, that is percentage of use, not the overall CPU being shared out. But for now, running fine. So let's run ourselves a little bit of a conversion. Let's go down to 720p to megabits per second. Again, no stress there. All the files there are still being held there in the background there for caching, just for later on. But again, still running fine. Coming along, no problem. So let's convert down a little bit lower. Let's go down to 240p. And again, with these artificial kind of scenarios that we're presenting here, I think that's running fine. There's a little bit of a delay, and you can see the CPU there spiking while we're doing some of these switcheroos between each of them. It's only taking a second to flick back and forth at this playback quality being streamed over the network. Let's go down to 160p. Let's carry on there. So again, running fine. There's about 8 pixels on screen if we're lucky, and it's still managing to carry on and play back through all of these media tests here. So again, that's quite successful. I'd say I expected this NAS to run all of these files very, very well. I'd go one step further than that. I think 1080p a conversion or not is going to run absolutely fine on this NAS, even though it doesn't have embedded graphics. It's 4K, where we're going to be particularly cautious of on this NAS. But for now, it's worth talking a little bit. I know I talk about this in other videos, so I apologise if this gets repetitious to anyone that's followed this series before, but it's worth understanding a little bit of the distinct differences, at least as far as client playback, between H.264, HEVC and HEVC 10-bit. As you can see, all three of these files are 3 megabits per second in HD quality, but on the end there, that compression technique is what's changed. Now, the oldest of the three is H.264. It's a very well established and borderline fully accessible compression technique for multimedia. Compression techniques are what allow files, when they do get released in cinemas at that enormous picture size, to get compressed down for for portability and of course playback on smaller devices, moving away from the likes of IMAX and more. Now, it's got a single pattern. It's not as efficient as HEVC, also known as H.265, but H.264 is the easiest to play back of the lot, although a lot of modern media, as it gets bigger and bigger, takes advantage of the better and more efficient and overall smaller output of HEVC, otherwise known as highly efficient video codec compression as well. So HEVC has a shared pattern across multiple sites. The result is that to apply for HEVC seamless playback on your client device, and indeed NASes and a lot of servers, is not as streamlined as it is for H.264. HEVC, therefore, often when it's played back, automatically needs to be compressed and transcoded in order to be enjoyed. So generally, HEVC files require more system resources in order to play them, even when they are practically the same size. If you have a look, you can see that both the H.265 and the HEVC file are both 10 megs. They're very, very similar in size. But because of that codec difference, the result is the system's going to need more hardware resources to play back an HEVC file, because HEVC does not allow you to natively and seamlessly play back the file. You have to convert it into another file state so it can be played back. And it's a very common thing. And it's one of the reasons that 4K playback isn't quite as seamless and easy as many people like. Now, 10-bit is effectively HDR, much higher quality there, and it's still utilizing it is only available in HEVC. So generally what you'll find is when you go to the higher end quality files, that you find that the 4K generally in HDR quality will always arrive in H.265, otherwise known as HEVC. So to put all of what I just said into perspective, if we play back the H.264 version, it plays back immediately. It's completely gone through, no slowdown whatsoever of this 1080p file there. Again, we can cut it down. It's a little bit more aggressive than the movies we've watched so far. This 30-second file is 2 megabits per second compressed now at 720p. So this is close to the picture quality of the 720p files that we were looking at the beginning, but still not quite there. And you can already see the CPU had to get involved. Had this CPU had embedded graphics on board, it wouldn't have been as high a spike, and indeed it would have been a much, much smaller spike, as the CPU would have had an embedded GPU and therefore graphic tailored components in its architecture in order to do this job for us. And again, we can take it down real low, down to 160p, where again we'll have virtually no pixels to play with, but it converted through fine there. So now if we play that same file, and we're going to play it with no transcoding that we action anyway on the HEVC file, you can see that it immediately, with no provocation from myself, says convert. Also, you'll notice there was a few seconds delay to play back the file. Lastly, look at the CPU. This relatively small file here, compared with the H.264 file, which again, near enough identical in size, as you can see there, HEVC and H.264 took significantly more hardware resources to play straight off the bat. Let's try that again. The H.264, we play back that file, no delay, go straight, and I say no delay, there was about 1 second delay there while we played it, whereas if we play back the H.264 file, little bit more of a delay there, as you can see, and of course the CPU spike is immediate. Now again, this is why transcoding is so important on the NAS when you want to play back these files, be it that you're going to stream it to your Amazon Fire Stick, watch it on your local Kodi box or Nvidia Shield or a Roku. Transcoding is going to be important, and that's why people look at these more powerful NASs in order to do it. But just know that when you are spending a lot of money on a NAS, chances are that the more enterprise level NASs do not have embedded graphics processors. They use CPUs like Xeons that do not feature any kind of onboard component. Lastly, let's try the 10-bit HEVC video file there. So again, we'll open that up. As it's HEVC, there's a slight delay as the conversion begins, as we can see there, and the file is playing. But again, CPU utilization exceptionally high. So again, to be expected, but again, watch the consistency and the delay moving forward as we go through these files. Now, if we convert this file, let's just go straight down to the lowest quality. Have a look at the bottom of the screen at that orange bar, that dark orange bar as it played it. Let's start that file from scratch again, and this time we're going to convert again. We're going to convert to 240p, and what's going to happen is, you see that dark orange bar? That is the file being redone in the background, and that is effectively like buffering. But ultimately, when you're playing back a file, the ideal scenario is that the playback of the file, like you're seeing here at the bottom, does not outpace the darker orange bar there, because that means the file is being converted slower than real time, which means it's going to keep stuttering when you play it. So now we've gone through the basis of HEVC, H.264 and 10-bit media. Now we can start making our way through the bigger file formats. So for example, all the H.264 files should play absolutely fine. So that's what I'm going to do. I'm going to play every version of H.264. So starting at 10 megabits per second, we'll open that up, plays immediately. You can see that dark orange filling up there, massively outpacing that of playback. And again, we can flick around. It's absolutely fine. Next, we can go on to the next H.264 file, which is a 30 megabits per second file. So now 3 times more than the file we just played and 10 times more than the first file. And again, transcoding there or buffering is happening much quicker than playback. It's all the way through. It's fine. The CPU barely breaking a sweat. Let's move it up a notch. Now we're going from 30 to 100 megabits per second. Remember, our first file was 3. We go to 100 megabits per second, and remember this is still 1080p. There's a slight delay there, a little bit of a bump on the CPU, as we can see there, happening there on screen. But again, we've got the transcoding and the buffering happening in the background, but this time it's only just staying ahead of pace there, and chances are it's not going to be able to outpace it. It's just staying ahead, but only gradually there. So we're starting to see the 1080p megabits per second limitation on this box. Let's move out of 1080p and go into 4K, and this is a 4K 120 megabits per second. So let's go there. I believe this is 40 times the bit rate of the first file we tested, and at a higher resolution too. So again, no transcoding happening here. We're seeing the file, and it stopped at 4 seconds there, as we can see, and this is never a good sign. This means that the file is just a little bit too dense for us to be playing back, and therefore that 4K for transcoding on this box is showing a little bit of a limitation there in how the CPU resources can be utilized here. Now, if we convert automatically rather than going back with the original file type, now we can convert this file and ask Plex to convert it in the best possible format for this intended client device. We've seen that giant spike there of the memory on the right hand side of the screen. We can come out there, and if we go back to the playback of the file, we can see that that buffering is taking place, with it reaching now up to about 7 or 8 seconds, with the file almost certainly playing back. I'm still not entirely certain that playback is not going to outpace that of the buffering there and the transcoding, but it seemingly has done it. Now we make our way onto the heaviest H.264 file we have at 200 megabits. Again, remember, 3 megabits right there at the beginning. So let's go back and play back this file like so. Again, we'll open up the monitor there. Chances are it's not going to be able to play back this file in its native state. As you can see, it's done that stop there. So rather than wait for it, we're going to go ahead and convert automatically. So if we play back that file converted automatically, we're going to see obviously a CPU spike as that file begins to be changed. Bear in mind, even the automatic conversion is still going to be pretty impressive, with the quality being almost exactly correct of what we saw before. But as we see, it's converting it there in the background. It's going to skip forward a little bit, and then playback's going to start in a moment. But let's see if playback will exceed that of the file being converted automatically by the Plex Media server to play back that file. CPU utilization is already looking pretty substantially high there, but it looks like it would still stay ahead of that of the internal playback there in real time, with it all the way through to the end. So now let's have a look at those H.264 files. Let's go straight in with the H.265 files, or HEVC. As we can see, this the 10 megabit file has been converted automatically, so that is already happening there in real time. It's converting that file, the H.265 file, and playback is definitely going to outpace that of the normal. The conversion is going to outpace that of playback there comfortably. So why don't we try something else? Let's try that 1080p file, the 1080p 10 megabits per second 10-bit file again, with it playing, with it converting automatically. But this time, much like before, what we're going to do is create multiple instances of playback at once. So again, we'll let that file play back. We'll play back the 10-bit file. And now our NAS has got to play that file in 2 separate instances at the same time. With it converting that file, let's see if it's able to do that job. And it's going to have more resources to do it. And it's a shame we're using a 30-second file, because it prevents us from running too many instances of this test at once. But what we can do is pause these files, restart the file, and then action our own transcode one by one. So we're going to run, again, the 10 megabits per second 1080p file. We're going to let that convert automatically. We're going to make this convert down to 720p. And then while that's going on, we're going to play the file again, and this time we're going to convert it down to, let's say, 480p. And what we want to see is how well this NAS is able to handle this very, very large task we've set it. At the moment, we're looking at playback. We've got playback there, one at the bottom starting to convert. And again, although system resources use was still pretty high, I still think between those we were able to play back that file moderately successfully. Again, let's come out of this. We'll try one more HEVC file. So again, we'll try the last HEVC 100 megabits file. Let's play back that one now. And then we'll end this video on the 4K testing there to see how it performs. Again, we've got the automatic conversion. At the bottom there, we're up to the 6-7 second mark. So let's see, is playback going to overtake that of the buffering? So we move forward through there. No, I think we're absolutely fine there. It's going to be able to do that. So that's a 100 megabits file there. So again, what we're going to do is we'll duplicate that tab and we'll play now 2 different instances of a 4K file. So what we're going to do is we're going to do 4K at 120 megabits per second there, and 4K at 120 megabits per second there, both of them in 10-bit audio. So this is a hefty hefty file that we're playing here. So again, 120 megabits per second 4K UHD, which again, if we go into our listing here, that is a half a gig file, almost 430 megabytes there. So megabytes. So let's go and play that file in both instances, the 10-bit version. We'll have those running back to back, and we'll see how that plays between them. So let's make sure we can have the monitor. Obviously, the conversion is automatic. And we can see how it does, converting those two files for us there. Obviously, it's going to be a little slower because now the resources are being pooled and shared between the two instances at once as it's converting both those files for us for playback. I believe the bottom instance of Plex is going to play first, but at this rate, playback is most certainly going to exceed that transcoding there. But let's have a look. We'll leave it to play back those files. I'm not sure there's enough bandwidth to play back these files successfully, unfortunately. As we can see there, nope, it hit that wall there all the way through. So having two large, and I really do mean 120 megabits per second, is a pretty large damn file there. So again, if we played one instance, I know that it would have played back that file absolutely fine. So for example, if we convert that down, let's try it again, that 120 megabits per second 4K file. If we play it natively, I think it's going to play absolutely fine there. It's going to go for that buffering period there at the beginning, which is what we're used to by now with HEVC. But right now, CPU utilization is getting quite close to capacity on this NAS. Just remember when we're looking at these tests to look at them in context. Context is incredibly important because we're not dealing with an everyday file here. This is an exceedingly heavy file that you're very rarely going to come across in traditional multimedia. We're just pushing this system to its very brink there. But as we carry on, the gap is closing, but I think we might get away with playback being fine here as it plays and buffers ahead on our file that we're going through right now. So let's end things on the biggest files. Right now we've got these two big monster files here. Again, I think they might play back, but given that we're already pushing utilization maximum here, let's go for them and just hope for the best. This is an HEVC 10-bit, so HDR 4K 200 megabits per second file. A monster file indeed. Let's open up the monitor there. Again, do remember we're using OBS to record this stuff here. And as we see, it's having a stab at converting that file, but it's certainly taking its sweet time there. Utilization is obviously quite clearly very high, but for now, let's see how well it does playing this HDR 200 megabits per second 4K HEVC file. I don't think playback is going to stay behind conversion there. I think if this was a full-length media file here, the NAS would be utilizing just way too many assets there to get this done. There are ways around this, of course. There's little extras you can do, but as you can see there, playback was faster than real-time conversion there within Plex. And largely that is because it doesn't have that GPU component on board. Now, again, we are still talking about a horrendously large file there. But nonetheless, let's look at the biggest possible file. This is our big test. Very few NASes that I've ever tested have been able to play back this file unhindered. I believe the RS3621XS Plus rack mount solution with an 8-core Xeon was able to play this. And we've tested a few Intel i5 core NASes which have got integrated graphics have played back this file with no hiccups. I think it will play on this NAS, but I do think at this maximum conversion quality, you're not going to see a 400 megabits per second 4K file being played on this right now. It's still a beefy NAS for Plex, but it's just not going to be able to outpace that. Now, had we done an automatic conversion, so we'll see what happens when we allow the NAS to, or Plex on the NAS to automatically convert and not just go for the maximum possible conversion within the context of highly efficient video compression. But now, no, it wasn't able to give it a stab. What if we go ahead and play back that file within there? So let's go ahead and play the file there. So if we go for the play, but this time start it off on something a little lower there. So if we bring it down to a high quality HD file, we can see just how well it would do. Again, CPU utilization absolutely huge. We can see that even though the system's got 16 gig of memory, the impact of memory on Plex Media Server still continues to be quite minimal in most of what we're doing here. But again, the file, even with the conversion happening, this 1.4 gigabyte file is just enormous. 1,400 megabytes there for 30 seconds of footage. It's a hell of a task and a huge graphical manipulation task that I don't think this Xeon has quite got the oomph for. But again, context everyone, context. 20 meg. This is an enormous file. Okay, so do bear that in mind. But I'm going to wrap things up here. This has been Plex Media Server testing for the DS3622XS Plus. Still a fantastic NAS. And nonetheless, although it's not really designed for Plex Media Server and more for business and enterprise users, and we're going to be looking at some VM stuff soon, let's not forget that this is still the most powerful desktop NAS from Synology's entire portfolio. And if you're looking for the most powerful NAS for Plex, I don't think you're going to do much better than this. Yes, you should really start looking at NASes with integrated graphics, and we have done Plex Media Server testing on their most powerful integrated graphics NAS currently to date, and that's the DS1520 Plus, 8 gig of memory and a 4-core Celeron processor. But for now, this has been Plex testing on this NAS. Click like if you've enjoyed the video. Subscribe if you want to learn more. And again, we will be continuing looking at every NAS that we see for Plex. Again, I have started testing some of the next-gen NASes out there with the next-gen Celeron in them. Unfortunately, none of the Synologies have arrived with that processor at the time of recording, but some other NAS brands have arrived with that CPU, and I'm pleased to say that CPU does a damn fine stab at playing some of those heftier files there. So I recommend checking out some of the more recent Plex Media Server tests that I'm producing in the next week or so. But otherwise, thank you so much for watching. If you need help choosing your Plex NAS, use the free advice section below, and I will see you next time.